Yes. So today we are going to discuss about the boundary value prompts of any order, okay, which are associated with the ODE. And there are some several methods, and we can use one of them. Two methods we have already discussed for boundary value prompts. Okay. Uh, One finite difference which we use only for first order. And yesterday we discuss shooting method which we can use for boundary value prompts, but in the same way we can use finite difference method also. Okay, so by using the finite difference method, how we can solve boundary value prompts, okay, whether it is a second order, third order, or higher order. So I will try to present here three different examples, and by extending the same, we can find out the solution of the boundary value prompts. Okay, so I should start by sharing my screen. And if you have any question, please don't hesitate. You can ask from me. Okay, so first I need to present my presentation, and then we will discuss everything one by one. And this will be very quite simple and easy approach to find out the solution of boundary value problem by using finite difference method. Okay, so you can see this is my desktop, and here is first I need to minimize. Okay, so Control and L. Yeah. So in the case of boundary value problems, we can solve these by using some specific method. Okay, so order differential equations and the boundary conditions when we are given, and what we do, we can discretize the domain. Okay, as we do for finite difference or for the shooting method. In the both cases, we always discretize the given interval. Okay, and here you can find select the discrete point within the sub-interval, and then we need to choose the method. There are four methods are there. One is finite difference method, finite element method is also there, shooting method, and spectral method. And two methods from these four we have already discussed. So the main approach to find out the solution of boundary value problem in both the cases, whether you are using finite difference method or you are using shooting method, in both the cases we need to reduce the boundary value problem into the initial conditions. Okay, and then specify the values of the function or the derivative of the boundary conditions. Okay, then when we will apply the discretized system solution for discretized system, then what we have, we will have the system of algebraic equations, and we will apply the iterative process for the convergence. Okay, so now you can see here there is one more file. Yes, so here in this we are using mainly in the first lecture we discussed how we can use finite difference method for the initial value problem. But here today in this session, we are using finite difference method for boundary value problem. Okay, and as you know, yesterday we discussed about the shooting method for the boundary value problems. Okay, these two methods are highly useful for different type of boundary value problems because of their convergence and easy implementation. Okay, so there is some similarity between this approach when we solve initial value problem by using the finite difference method. So the approach will be same, but we are discussing with the one example. Okay, so here you can see, here we have one example, and okay, so we have, this is the second order, y double dash x is equal to minus 2yx, and x lies between 0 and 1. Okay, so this is the interval 0 to 1. and this is the left boundary value and this is the right boundary value for this problem. So first we will discretize to implement finite difference method. We need to discretize the domain. So here we will divide this domain into n plus 1 equal spaced point with n intervals. So when we will have n intervals and xi will be equal to ih, and where h will be equal to 1 upon n. This is the step size, length of step size. Okay, and I will vary from 0, 1, 2 up to n. Okay, so this is the interval, and at this place we have 0 and this is 1. This point is x0 and this point will be xn. Xn will be equal to 1. Okay, and these other are the intermediate points. Okay, this will be the x1, then x2, and so on. This will be xn minus 1. This point is xn minus 1. So here we are given y naught, and at this place we have yn. Yn will be y1 is equal to 1, and y0 means this value. Okay, so we when we will apply finite difference method, just we need to compute or calculate these intermediate values x1, x2, and xn minus 1, and the other, these are the boundary value problems, and but we have these points are xn minus 1. It means if these are the unknowns, then there will be n minus 1 system of equations, and after establishing these equations, n minus 1 equations or system of equations, we will take the help from we will reduce this system of equations in the matrix form. Okay, and then we will apply the MATLAB code to compute all these intermediate values. Okay, so the approach is we need from the finite difference we have y double dash x, and we are using here central difference. Okay, in all the cases we always use central difference, and see y double dash xi will be equal to y xi plus 1 minus 2 y xi plus y xi minus 1 upon h square. This is the second order finite difference, central difference. Okay, all these has been discussed in the very first lecture when we start this finite difference. And also, if you need the first order, once again I am repeating, y dash xi will be equal to, this is also required in the today's session. Okay, yi plus 1 minus yi minus 1 upon 2. And if you need this third order, okay, in this session we choose the problems up to third order. So the central difference for third order, we will have y third time prime is equal to yi plus 2, then we have minus 2yi plus 1. Okay, 2yi plus 1, and plus we have is 2yi minus 1, then minus yi minus 2 upon h square. Okay, so this is used for the second order, this is the first order, and this is the third order. And upon we have, sorry, third order, in the case of third order we have is 2h cube. Sorry, here is 2h cube. Okay, so this is for the third order. So these expressions are required to implement finite difference method. Now, for our this above problem, we will use this one, central difference, and when we will apply, so here we are choosing n is equal to 4 and h is equal to 1 by 4, xi is equal to I upon 4. Okay, and I will be equal to 0, 1, 2, 3, and 4. So what is there? When you will put this value in the given existing problem, okay, we will have 2yi plus 1. We will have 2, we will have yi plus 1 minus 2yi plus yi minus 1 upon h square is equal to minus 2yi. Okay, and after simplifying, we will have the above equation will be reduced into in this form. Okay, so the values which we are given here is y0 is equal to 0 and y4 is equal to 1. Okay, so actually, for the initially and easy to understand, we have only this is the x naught and this is x4. Okay, and x4 is equal to 1 and x0 is equal to 0, and these are this is x1, x2, and x3. The value at this point we have is y naught and y4. Okay, these values are known values, and y1, y2, and y3. These values are unknown, which we need to compute and we need to find out. So actually, the thing is this value of h, or the number of points in between these 2 points. We will take the large values, but in the beginning to implement how we can establish the matrix and then how we can write the code, then we can choose h as small as possible, depend upon our choice. Okay, and as you know, the size of h is much as small, we have more accurate value. Okay, but in the beginning, how we can implement and how we can establish the system of equations, and then from the same we can generalize for the small size, okay, or the large value of n. But here n is equal to 4. When we will implement, we will choose n equal to 100 or more than 100. Okay, so from this equation, the equation which we just now simplify here, what we do, we will put I is equal to 1, I is equal to 2, 3, and 4 in this equation, and ultimately we have equations. Okay, just now I have to close, and okay, and this one I have to open one more file. Okay, and I have to close new file. Just 1 minute, I have to open new file. Yes, okay. See here, the equation which we have is the equation after putting the finite difference, we have y, just 1 minute, this is very large size. Okay, y I minus 1, and then we have minus 2yi, and plus we have is yi plus 1 and is equal to minus 2h square yi. Okay, and along with we have y0 is equal to 0 and y4 is equal to 1. So these conditions we are given, and this is the iterative relation. So what we do, we will put the values I is equal to 1, then I is equal to 2, and I is equal to 3. These values we need to put in this above equation, and when we will have I is equal to 1, this equation will be reduced into y0 plus minus 2 y1 and plus y2 is equal to minus 2h square y1. So this is the first equation, and when you will have I is equal to 2, from this equation, you can say this is equation number 1. When we have I is equal to, from equation number 1, we have y1 minus 2y2 and plus y3 is equal to minus 2h square y2. And when we have I is equal to 3 from the equation number 1, we will have y2 minus 2y3 plus y4 is equal to minus 2h square and y3. Okay, but the value of y0 and that of y4, we are given these two values. We will use these values in these three equations, and these three equations will have unknowns. These are y1 and y2 and y3. These are three unknowns. So what we do, we will rewrite these equations in this form. We have y1 from this place common, and first equation can be written as minus 2 1 minus h square y1 plus we have is y2, and the coefficient of y3 is 0 is equal to minus y naught, but y naught is again 0. Okay, and from the second equation we can write in this way. This is y1, and then we have plus, sorry, this is minus, here is minus 2 1 minus h square y2, and plus y3 is equal to 0. Okay, and from the third equation we will have 0 y1 plus y2 and minus 2 1 minus h square y3 is equal to minus y4, and the value of y4 is 1, so this will be equal to minus 1. So from these three equations we can easily reduce in matrix form. Okay, so this will be minus 2 1 minus h square 1 minus h square. Then we have from the first equation coefficient of y1, coefficient of y2, and coefficient of y3. Similarly, from the second equation, coefficient of y1 is 1, and that of y2 we have is minus 2 1 minus h square, and the coefficient of y3 is 1. And from the third equation, coefficient of y1 is 0, and that of y2 is 1, and y3 is minus 2 1 minus h square and y3. This is y1, y2, and y3, and is equal to, we will have 0 0 and minus 1. Okay, so this is we have is A matrix, and this is we have is B. Okay, now from this by using the matrix we can easily find out the solution of these three system of equations. But once again I am saying that if we will divide the given interval by taking n is equal to 4, we have three equations, and h will be 1 upon 4, but we can reduce the size of h. So as much small we have the size of h, or the step size, we have more accurate solution. So now we are implementing this one in MATLAB. But see here, this is the value of A11, and this is A22, this is A33. So we can write AII. So the value of AII we will have is this one. Okay, this is the value of A21, and the value of this one, this is A32. So these both are equal 1. And in the above, this one and this one, these values, what about these values? This is A 1 2, and this is 2 3, both are equal to 1, and the other elements are 0. Okay, the other elements are 0. Okay, and the now we can easily apply our algo in MATLAB. Now I want to minimize this one and come to the MATLAB. Yes. So this is the example and the part of implementation in the MATLAB. Okay. So here we are choosing n is equal to 100. So if you will take here n is equal to 4, then this will compute the value of y1, y2, and y3. Okay. And as you know, when we will have n is number of steps, number of the points will be large. Then we have small step size. And when we will have the small step size, we have more accurate solution. Okay, so now come here, this part. See, this is important. Only this one. Okay, see this one very carefully. So here we have is I minus 1. These are the values A11, 22, 33, and so on. And all these values we have is minus 2, 1 minus h square. Okay. And if I will open, yes, you can see this matrix. These are A11, 22, and 33. And if you have the large number of points, then we have large number of unknown values. And corresponding, we have the number of rows and number of columns. Okay. So here, what about these values? Okay, so what about these values? When you will have I is equal to 2, so this will be A21. This is A21. When you will have I equal to 3, then 3, 2. So all these values are equal to 1. Okay, below the diagonal element. Okay, and what about this one? These are the values. These are the values above the diagonal element. When you will have I is equal to, then this will be 2, 3. Okay. And when you will have I is equal to 3, then this will be 3, 4. So all these values are equal to 1. Okay. So the entire matrix is written at this place. But in the case of boundary value problem, these are the boundary values. Okay. These are the boundary values. So the boundary values, when we have A11. A11 means, what do you mean by A11 and A and N? See, once again, I have to delete this one and then, yeah. So see at its place very carefully. This is X0. This is X4. Okay, suppose we have this point. This is X1, X2, X3. Okay, and here we have is Y0, Y1, Y2, Y3, and Y4. So these values, okay, means X0 and Y0. And in the case of index, this will be 1, 1. When you are using index, this will be X1, Y1. Okay, and in the matrix, this will be A11. Okay, so values corresponding to this one and this one. This will be NN, last value at this point. A, N, and N. So these values are equal to 1, and these are A and N. Sorry, the boundary value. Okay, boundary conditions. A11 is equal to 1, and for the value of B1 we have is 0. So this is the Y0 is equal to 0, and this is this value Y4, which is -1. Okay, and A11 and ANN. So when you will have the matrix, the very first value in the matrix will be 1 at these end points, because the matrix which we established was corresponding to these one. Okay, so when you will choose the coefficients for this equation, when we will have X0 and corresponding to Y0, the coefficient of Y0 will be 1, and for that of the coefficient of Y4, that will be also 1. So that's why we have 1 and 1. Okay, and the other the system of equations we have is the coefficients which are y1, y2, y3, and corresponding to these coefficients, we have the matrix A. These are the corresponding element. Okay, so this is all about to write the code to convert the system of equations in MATLAB. But along with we have to apply the boundary conditions, and the boundary conditions will be applied in this way. Okay, so other part to compute are very simple. I have to minimize. Yes, now come here. So here we are choosing, you can choose n equal to 4, depend upon our requirement, the number of grid, then L, this is the length of interval, and H is given by, as H is a step size, that will be L upon n minus 1. So first what we do, we will discretize the domain X. Okay, so this is the discretize the domain X. Then we have A, zeros of A and zeros of B. Okay, so A zeros are, the size is n by n. This will be always a square matrix. And that of B, we will have only column matrix. Okay, and this is the initialization of matrix A and vector B. After that, this part we have already discussed. This is the setup of a system of linear equations, and these are the boundary conditions. And to find out the solution of this linear system, okay, because we have the system of equations, and we convert all the equations in matrix form, and to find out the solution, you will use y is equal to a backslash b. This will give us the solution of the system of equations using matrix. Okay, so all these points are converted easily in the matrix. Then we can come to plot the values. So here these are the statement to plot the graph. Okay, and when you will execute this sequence of a statement and see, we have these 3 point enter. Okay, we choose here h is equal to 4. So we have 4 point, and when you will choose n equal to 5, when we will have n equal to 5. For 5 intermediate values, we have to choose n equal to 5. Okay, so there will be 5 point, and yes, now it is fine. It is fine. It is fine. You can see on the left hand side we have the left boundary, and on the right hand side we have the right boundary. Okay, and the other are 3 are intermediate points where you can see the circles. Okay, so these are the 3 intermediate values which you can see the corresponding value of these expressions. Now again, if you make more small size, if you will have n is equal to 100, now you can apply for the small step size or the large number of points, and you will have this graph. Okay, so in this way we can easily find out the solution. I think there is one problem, and the problem is that bn, if you will take this is positive, the right boundary is 1. The right, when we have x is equal to 1, y is 1. Okay, and when we have x is equal to 0, y is also 0. So in the left hand side, x 0, y 0, and on the right hand side we have x equal to 1, y equal to 1. So this is the correct answer, and you can compare. So all these are the intermediate values has been computed, and you have the required solution. So in this way you can easily implement this finite difference for the boundary value problems, and very simple approach. Just you need to discretize, and if you have the higher order, okay, whether it is a third order, we discuss here only second order. If you have third order or fourth order, you can use this finite difference for any order of differential equation. So first, let me know if you have any type of question regarding the implementation of this finite difference for boundary value problems, because in the previously we use this finite difference only for initial value problem, but the same approach we can use for the boundary value problems. If you have question, please feel free to ask from me. Yes, over to you.
Sir, I think we have to give value to bn minus one, because in our
Yes, yes,
system
yes.
3 × 3 we have to
Yeah,
give value.
yes, just 1 minute. We need to check. We need to check. I think while writing, I have some problem. The equation. Okay, in the statement. Okay. Y1. Yeah, while computing, after computing, when we reduce the equations.
Sir, you
Okay.
have explained that we मतलब uh, जो matrix है,
Yes.
in
Yeah,
that
yeah.
matrix we
In the
have
calculation,
-1,
yeah, yes. When we simplify, it was -1. Yeah,
-1, and
yes,
it should
you
be
are
of
right, ma'am.
bn -1,
Yes, you are
because
right.
we are considering
Yeah,
only
yeah.
2 3 -1.
Yes, ma'am, you are right. This is -1. Please make it correct. Yes. Thank you, ma'am, for the observation. Yes, this is -1. Please make it correct. Y1 is equal to -1, because when we convert this in system of equations, in that case, at the end we have this value. In the MATLAB, we check that, yeah, this is -1. Yes, this is -1. Now it is fine. So please correct the statement, and according to that we have is -1. Yeah, and when you will execute, now it is fine. Okay, so according to the statement, we have the same solution. Any question, please? I think everything is clear. Everything is clear. If you any doubt, please you can discuss so that we can go for the next example. No question. Okay. So here you can see we have one more example. In the first, we have only this type of problem. Y double dash x is equal to minus y double dash x is equal to -2yx. Okay. First order missing in this example. But in the next example, which we are discussing here, the equation is in this form: y double dash x plus 2y dash x plus yx is equal to 0, and y0 is equal to 0, y1 is equal to 1. Okay, so in this case also we will use the finite differences and the expressions which I already explained in the beginning. So when you will put the value of y double dash x, then y dash x, this equation will reduce in this form. This equation will be reduced in this form. Here you can see, after discretize the above given ordinary differential equation, I write here in the form of LaTeX format. Okay, so this will be the 1 upon x square. Then we have yi plus 1 minus 2 yi, and plus yi minus 1. Okay, so this is corresponding to y double dash. And for the value of y dash x, this is again we are using the central difference, and this will be 1 upon 2h yi plus 1 minus yi minus 1, and this is yi. And after simplifying, this expression will be reduced in this form. And now again we will use the same way by taking I is equal to 1, 2, 3, 4, and so on, and we will have the system of equations, and we can easily convert in the system of equations, then convert in the matrix form, and then write the code. Yes, so here you can see the values that corresponding to the diagonal element a11, 22, 33, and so on. All these will be equal to -2 minus h, and -2 minus h. So these will be the coefficient of this middle term. These will be the coefficient of this middle term, and the coefficient of this term and this term both are, you can see, 1 1. Okay, and here you can see the when I will be greater than 1. Okay, I minus 1 is equal to 1, and when I will be less than n, in that case we have is also 1. So these are the element corresponding to the above main diagonal element and below the main diagonal element. Okay, so all these elements are 1. So this is the another way to set up the matrix and write vector b. Okay, so bi will be equal to minus h square when we will simplify these equations. And these are the same boundary conditions. Y0 will be equal to 0, and that can be written as b1 is equal to b1 minus x1, and y1 will be bn minus xn plus 1. And then you will use y is equal to a backslash b, and this will solve the system of equations which are in the matrix form, and these are the same statement and will return the solution of the above system of equations. When you will execute, you can see the solution of the boundary value problem. Quite easy. Okay, any question?
Sir, here boundary condition.
Okay, boundary conditions.
Yeah, it is in a different manner.
Yes, different manner. These are in a different manner. Different manner.
Shall you explain more these boundary conditions? How?
Pardon?
Okay. Shall you explain more how we can write the boundary condition in this form?
Yeah. We can explain.
Okay.
So when you will put these values in the system of equation, actually when you will reduce the comeback at this place. Okay. So when you will put the values of I equal to 1, 2, 3, 4, and so on. Okay, so from the first equation, we will have this value b1 and minus x1, b1 minus x1, and this will be the bn. The value of bn, just 1 minute, b1 minus x1. X1 we have is 0, and the other point we have is 1. When we will have n plus 2, so this value is 1. Okay, xn plus 2 1. See, yes. So this equation you can write as y0 minus 0, b you can write as b. Okay, say this is the first boundary value. Okay, and this expression, this is the first one, and index is 1. Okay, and this is the first value, and this is only x1. Okay, the x1 is 0. X1 is 0. So you can write 0 as x1. And from this part, you can write as minus 1. Okay, so this is the value at the end point. Value at the bn is equal to we will have bn and n plus 2. Okay, actually this will be clear when we are using the reducing in the system of equations. Then this will be quite easy to explain. So this is the value ybn, and system of equations will be n plus 2. See, these are the points, and here is x naught, and here is xn plus 1. This is xn plus 2. Okay, and xn plus 2 is equal to 1, and bn will be bn.
So bn is 0 initially.
bn
We are giving 0 value to all b. So,
pardon?
sir, bn is 0. We initialize b vector b to 0. So here bn is 0 and minus xn plus 2. Xn plus 2 is 1. So 0 minus 1. That is the value of bn, new bn. This bn is 0.
No. bn.
Sir,
This is the
we
just
giving
1 minute.
value 0 initially.
I is equal to, we have is 1 to n. Okay, so the value n is 100. N is 100. Okay, so this is the n equal to 100 means this is the last row. This is the last value. Okay, this is the first value and this is the last at the end. Okay, so if you will take the particular case, this will be fine. Suppose we have is, just 1 minute, interesting question. We are taking here n equal to, suppose we have is 4. Okay, we are taking n equal to 4. And according to that, we will do. So the equations which we reduces at this place we have is this equation. See this equation. This is, we have is yi plus 1 minus 2 plus h yi, and plus we have is y I minus 1 is equal to minus h square. Okay, so when we have I is equal to, we will start from I equal to 1. So this will be y2 minus 2 plus h y1, and y0 is equal to minus h square. Okay, then you will take I is equal to 2. This will be y3 minus 2 plus h. This will be y2, and y1 is equal to minus h square. When we will have I is equal to 3, then we have y4 minus 2 plus h y3, and this will be y2 is equal to minus h square. So the value of this part and this one we are given. Okay, these values we are given. So when you will reduce this one in matrix form, so the values of y1, y2, and y3. See, actually we have three equations, y1, y2, and y3. Okay, but here we have is when you will take the entire interval. So in that case, we will have at the place y0 also, and at the place we have y4. Okay, and for that we need two more equations. One will be corresponding to this one and this one. Okay, so when you will compare the coefficient, so the matrix which is reduces are corresponding to this one, but these are the boundary values. Okay, now this will help you. So on the left hand side, uh, we have is y0. Y0 is equal to, we have is y0 is equal to, we have is 0. Okay, so the coefficient of you can write, because this is the constant value. Okay, and you can write on the right hand side. So corresponding to this, all the constants will be on the right hand side. So this value will be y0 minus 0. Okay, and the first index we have is b1. The first index is b1, and this you can choose x1. Okay, b1 x1. So that's why we have this equation just now. Just 1 minute. Minimize and scroll down. Now this will help you to understand. Yes. So this equation, which is constant and will be on the right hand side. Okay. So this can be written as b1, and 0 is x1. Okay. Now when you will be at the space, there will be the 1, 2, 3, 4, and 5. 5 equations will be there when you will include the boundary points also. Okay, but these are the unknown. We will compute only these values. But also when you will include the boundary points in this, then the value corresponding to when we have x4 and y4. Okay, so we have the equation is this value. Okay, y1 is equal to 1. You will write it as y1 minus 1, and suppose it is bn. Suppose it is B. Okay, B. But what is 1? 1 is equal to 1 is equal corresponding to this one 4. Okay, 4 is the value of n. 4 is value of n. But the equations we have is 3. 1, 2, and 3. So this is 4. Okay, so this is the value of n. That's why we have is Bn. We have is Bn. Okay, this is the boundary. We will note it as Bn. And the point for 1 we can this is the last point. The y4 is corresponding to the last point, and last point is also we have is n. Last point we have is n. So this must be xn. This must be xn. Okay, this must be xn. I think this is incorrect. Bn and Bn. At this place we have 2 is incorrect. 2 is incorrect because this is the last point. This is the last point when we have xn, yn, right boundary value. That is also constant. So that constant value can be written as in this form. Please correct it. This is not n plus 2. This is only xn. Bn is this one. Okay. And 1 is the value of x on the right hand point. So these initial and left boundary and right boundary we can write in this way. Got it?
Yes, sir. But check it here in MATLAB. After remove the 2, we will see the result.
Okay, after removing the 2.
Yes.
We can check it. We can check it. Okay, line space we are taking here is yes. Line space we have is n plus 2. Okay, the line space is n plus 2 and B zeros are n1. See, actually the thing is the last point of X array is n plus 2. Okay, the last value of X is we have is at the point index is n plus 2. Okay, and that of for B is we have n by 1 vector. So there will be 1, 2, 3 up to n means 100 tak. Okay. So corresponding to this array and this vector, this matrix, this vector and this vector. Actually, the x vector is the last value is n plus 2, index is n plus 2. That's why, sorry, it is now correct. The last index is n plus 2 and that of for B we have is n. Now it is clear. This we are writing in this way. The last value of B is, as we choose at the place, last value is n, and for that of x we have is n plus 2 index. We divide x 0 to 1 is in the point n plus 2. That's why x we will have n plus 2 at the place. Is it clear now? Is it clear?
Yeah. Okay, sir. Yeah, this depending upon the
yes,
definition there of the line space.
Yes,
okay.
yes.
Okay, got it. Thank you, sir. Thank you.
Yeah, now it is fine. But if we change it, this will create a problem because the length of the vectors must be equal. This is also returning the same value. Okay, 0 to 1 and 0 to 1. And if we will choose this value, then is also it is returning. But the correct is we have to take at its place n plus 2. Okay, we have to take n plus 2 because of the length of x vector. We have to follow the rule. Okay, sometimes incorrect statement also return the value, but not correct. So we have to follow this length. This is the for the last value, the index is n plus 2, and that of for B we have is n. So this equation we are reducing in this way. Very critical sometimes, and the other things are same. I think it is clear. Okay.
Yeah, clear, sir, clear.
Okay, so here is one more example, and the statement, yes, the statement is at this place. Y triple dash is equal to minus y. Y triple dash is equal to, this is third order. Okay, and you can use this approach to find out the solution. And here is also, we have one more example for third order. Yes, check it. This is the same way as we do in the first example and second example. Here we are given the values y dash 0 is equal to and y1 is equal to 0 and y0 is equal to 1. This is the left boundary and this is the right boundary, and y dash 0 is also there. Slope of tangent we are given. Okay, so we have to apply these three values to find out the solution of this equation, but the approach will be same. So what we do here, yes, okay, come here. So this is the first boundary value, y0 is equal to 1, okay, and y0 means y1 because the index is 1. That's why we have is y1 minus 1, and we symbolize is f1. Then the second condition we have is y dash 0 is equal to 2. Y dash 0 is equal to 2. So for this we have to use the central difference for y dash. Okay, and the same we have is yi plus 1 minus yi minus 1 upon 2 h. 2 or 2h for y dash. Okay, so when you will have I is equal to 2, this will be when we will have I is equal to 1, so this is y2 minus y1 upon 2h, and the index for this will be y3, and for the same for this one is I is equal to I equal to 2.
2, sir.
I is equal to, then we
Yeah,
have
y3 minus y2.
this is
Yes.
3 and this is 1. Okay, so this is y3 minus y1 upon 2h, and this is minus 2. Okay, and in the same way, when we will have this is the last value. This is the last value. When we have is interval we have is from 0 to 1. Okay, so this is the last value, and say it is n plus 1. Okay, if you will divide the entire interval x n plus 1, and for that we have is y n plus 1. Okay, so this you can write easily y n plus 1, and we will store for f n plus 1. So these are the boundary values and the intermediate equation. See, this is the intermediate equations, interior points which we need to compute. And how you can establish this equation? Just you need to put all the values of finite difference, all the values of the finite difference by using y dash, y double dash, y triple dash at this place. So when you will put the values of by using central difference for y triple dash, y double dash, y dash, and this will be yi. So when you will simplify this equation, this will be reduced in this form, this one. Okay, and all these we will store in fi. Now the interior points will start from I equal to 3 to n minus 1. 3 to n minus 1. Okay, so here is f1 and f2 already, and it is fn plus 1. Okay, and the interior loop points are from I equal to 3 to n minus 1. 2 on the left hand side, 2 from the right hand side. We will exempt 2 point in the beginning and 2 from the end point. So this is the loop for to compute all the interior points, and the other thing are same. So what you will do, we write here the function which is finite difference. Okay, there will be two arguments, one will be y and other will be h. So following the same, n will be equal to length of y minus 1, and f zeros will be zeros n plus 1 to 1. Okay, and now we need to compute. Here we are using the next function as we discussed in the very beginning, next function. So this is the main function. This is the main function. N is equal to 0, n equal to 100, h is equal to 1 upon n, and these are the initial values for y, zeros, n plus 1 and 1, and then after we will use f solve function. we are using f solve function and at the rate y, and we want to solve for y. The meaning of this one is we want to solve for y, and this is the finite difference which we write at the below, and these are the initial values. Okay, and then these are the statements to plot the graph. So this main function will be at this place, and then yes, and this is the function for finite difference which we establish here. And when you will execute, we have this graph. Okay, so there are two ways whether you can use all these in this way also, as we discussed in the first example or second example. You can easily convert in the matrix form, or if you have you want to use in the single equation, you can use these equations in this format also. Okay, you can use this format in the first example, in the second example. Okay, and first and second example you can use for this problem also. Okay, so there are two ways to find out the solution by using finite difference approach. This is one more. Okay, so I think is there any question in this example? Any question in this example? Yes, please. Any question in this example?
Sir, F solve for solving system of equation.
Yes, f this function will solve the system of equations.
Okay.
Okay, because all the equations will be generated from this place when you will take I equal to 1, 2, 3 and so on. But we need the intermediate values. Okay, boundary values are at this place. These are the boundary values, initial and last, and for y dash 0 also. Okay, these are the boundary values, but we need to compute interior points. So these interior point will be computed at a place, and this approach you can use for the first example and second example also. You must try yourself. So I try to present both ways. This is also one more way to solve the differential equation. Okay, here is, you can see y triple dash is equal to minus y. Okay, and we can use this approach as we discussed yesterday in the shooting method. Okay, so you can reduce this equation in the first order ODE. By reducing any order, you can reduce in the first order, and then you will have the system of equations, and you can implement this finite difference approach. So here you can see y1 dash is equal to y2. Okay, and y2 dash is equal to y3, and y3 dash is equal to minus y. If you choose y1 dash is equal to y2, y2 dash is equal to y3, and y3 dash is equal to minus y1, and ultimately when you will combine all these equations, you will have this equation. Okay, so here this is the approach how you can reduce any order in the first order differential equations, and then you can easily apply the same to find out the solution. And here is, suppose length of the interval domain is 1, n is equal to 100, and this is the value of length of the h or grid space, or the value of h, that will be L upon n minus 1. This is the discretized domain. Okay, and now we have the function of these three equations. One is y2, y3, and start from this place, y2, y3, and minus y1. Okay, so these are three system of equations. Okay, and these are functions of x and y, and we are using here anonymous function. After that, now you can easily come to the boundary values, boundary conditions. Y0 is equal to 0, and this is the y the other boundary value, that is again 0. We denote as in this way, and y double dash 0 is equal to 1. So we denote it by y2 0 is equal to 1. Okay, so now discretized the second derivative using finite difference. Okay, so here is d2 is equal to we have is 1 upon dx square. So what is about this one? What you know about this expression?
This is a finite difference.
Yes, second order finite difference. Okay, and which is the second finite difference we have is yes. So you need to learn to implement, and this will be possible when you will use yi plus 1 minus 2yi and plus yi minus 1. Okay, and is upon h square, okay, so started from this expression.
Sir, this third order.
Yeah, so for the
Third
second
order,
order. Yeah, for the second order
Okay.
we have this one. Okay, now this will be these are the element of the main diagonal element. Okay, and this will be the this element, this will be the this element. Okay, so all these are diagonal element. So you can write this expression in this way. And these are what about this one? This will be the excluded boundary points which we need to uh, because these values are for unknown values. Okay, and the end point, the values at the end point, at this value and at this point. Okay, these are at this place, these are the end values, exclude boundary points. So these points we need to exclude. Then we have the construction of the matrix, which is ay is equal to b. Okay, so what about this one? What is I? What is I?
Identity matrix.
Yeah, identity matrix. Okay, this will be the identity matrix of this order and minus d2. Okay, b zeros will be in this way, and this is the boundary value. Okay, so after applying all these, we have the system of equations in the matrix form, and then after you need to study these very carefully. Okay, just 1 minute. I have to, yes. Okay, so here after that we will calculate the system of equations which are the based on intermediate values. Okay, exempt the boundary values, only we need the intermediate values that will be computed by this equation as we do for the other examples. The same approach is here, and assemble the full length full solution. That will be, this is the y naught, then we have this is the first value and this is the last value, right boundary value, and these are the inner point. So this is the complete y vector, and then we will plot the solution. So this will return the solution of this system of equations, and when you will execute, you can say this is the corresponding graph. Okay, so here I tried to present 3 different examples, 4 examples, and I hope that this will help you. If you have any question, please feel free to ask from me. Any question, please. I tried to justify everything from my side, but still, if you have any question. Imtiaz Ahmed, Dalip Kumar Mishra ji, Namaskar. Disha Shah, Maridula Jain, good evening. And Yahya, please let me know if there is any question. Sahid Alao, how are you?
I'm fine, sir.
Great.
Thank you for today's lecture, sir. Very great.
Yes, actually, the thing is that the method which we discussed yesterday and today, shooting method as well as finite difference, there are so many problems, and for different type of problems which are associated in medical science, in control system, control theory, fluid dynamic, and system of equations, models which are associated with the health science, like SIR model. So there are so many applications about these two methods, and highly used for different type of problems, and provide us more accurate solutions. But I think yesterday I present only one example. I will try to prepare some more examples because shooting method is also very, very important and highly, there are so many applications. But due to my health issue, I was not able to introduce some more examples, but I will prepare some more content so that this will help you in many ways by taking some more examples from other basic sciences like physical problems or control system, or from the health science. We can there are so many problems which are exist in the chemistry. I saw many examples yesterday after the session. So some literature part is missing. That is also very important. I prepared the content, but I was not able to upload the same. So today means today no, tomorrow morning I will convert in the PDF file. Then I will share with you in the group. And tomorrow dear participant, tomorrow there will be some change in the schedule. I will be out of station after 7 p.m. I have to travel. So I want to take your session tomorrow in the morning. Okay, so if you will be able, it's fine. Early in the morning, about 10 or 11 a.m. So I will I will send the message as soon as the content for the tomorrow will be ready. Because afternoon, I will not be able to deliver my lecture. So for the tomorrow, we have to change this schedule. Okay, and I hope that tomorrow you will join the session and you will enjoy. And if you have any problem which are based on finite difference and shooting method, please share with me so that I can prepare, or I can provide the solution. So this will help you. Sometimes if you have the problem, and you must share with me so that in the coming session we can discuss or we can introduce the same. Any more feedback from your side? If you can suggest, please share the problem. Yes, ma'am. Maridula, yes, I will share the script file all which we discuss today, yesterday, and also some content are pending in the last week also. So yes, I will try to upload all the content tomorrow before going to out of station.
So
Okay.
the content of shooting method, I don't know if you have uploaded
Yes,
it.
yes. Some yes, you are right. Some of the content.
Around yesterday.
Yeah. We will upload all the content. Okay, the last 2 weeks I was very quite busy, and also I have health issues, so that I was not able to upload all the content, the recording. Okay, the recordings of each session are ready. Only yesterday and today's session are pending, but other recordings has been uploaded. You can find on the playlist of YouTube channel. Okay, all the recordings we have uploaded. Only 2 sessions are due: yesterday's session and today's session. Okay, these 2 sessions we will upload it by tomorrow. But other recordings we have uploaded. But the contents we need to upload for you. Okay.
Thank you, sir.
Thank you very much. So it is time to close the session. Thank you very much to join me, and good night. Tomorrow we will join in the morning.
Good night, sir. Good night, sir.
Good
Thank
night.
you